R Studio? Okay, great. Good. So, welcome once again to this database series organized by the ASAP student chapter here at UTEP and the data science department. So, if you've been following, this is the second. This is the second part. So this is going to be like a series of different database applications where we started with looking at what the Tableau. Okay, so we had that for 2 weeks, and I believe that we are now confident, or we feel confident than before about using Tableau. So today we are continuing, and what we have is what? App development using Shiny. Okay, so what is Shiny? But before that, I want to make a disclaimer. Okay, this is not a database class, unfortunately. Okay, so what I mean by that is this workshop is not going to teach you, the focus is not to teach you how to make good or impressive data visualizations. Okay, the focus is to be able to help you publish your work. So the assumption is that we already know how to do some steps in R and how to do basic data visualization. So let's just keep that in mind so that we wouldn't be disappointed at the end of the day. Okay, that's not part of, that's not the goal. So we assume that each and every participant is familiar or cool with basic data visualization principles. So my name is William, for anyone maybe who is seeing me for the first time. I'm William, and a PhD student here at UTEP in my 6th semester. Yeah. Okay, so yeah, that is a little bit about me, and I enjoy coding. So if you have fun coding, maybe we can meet up and just chill with codes. Okay, so today we are looking at what? Our Shiny app development. And this is more of introductory session. Okay, so before anything, let's do some housekeeping. Okay, so I just want to make sure that everyone has the Shiny installed. So Shiny is an R package, just like any native R package. Okay, so once again, I'm assuming that you are familiar with the R programming environment. Okay, so Shiny is just like any of the native R packages that you are used to. Okay, so more about that later. And then, so that's the required package. Okay, once you install Shiny, I know it has a lot of dependencies, okay, but you don't have to worry about that. If you are connected to the internet, it should be able to install the necessary dependencies for you. And other subsidiary packages that we will need, we'll be using ggplot2, the plotly, the data tables, and dplyr, and then there's this advanced version of ggplot2, which is called the ggextra. Okay, just to help you create some complicated plots. Okay, so if you have the Shiny app installed, then you are good to go. You don't have to worry about the rest, okay? And we may be using the other packages, maybe mostly in our second session. So this is going to span over a period of, 3 different meetings. Okay, so we'll be meeting 3 times. This is part 1. Part 2 will be coming your way around March 22nd. Yeah, on March 22nd, after the spring break. And then after that, we will have our final session, the part 3, to conclude everything. That will be on the May 5th, correct? Yeah. Okay, good. So this is part 1, and it's going to be more of introduction. All right, so just make sure you have these installed. All right, so like I said, as part of my disclaimer, so I assume that you know a little bit of R. You can perform some basic statistical analysis, including like data preparation. Yeah, data preparation like EDA, which encompasses your data visualization that I talked about, and then some statistical modeling, okay? You should be able to run some models. And like I said again, you should have fair understanding of data visualization principles. If this is the first time you're hearing the formal expression data V's, I would recommend this book here. I don't know if you can see. Okay, so there's this book called Storytelling with Data. Okay, a data visualization guide for business professionals. And this is written by Cole Nussbaumer, who once worked at Google, I think Google Analytics or something. Yeah, so I like this book. I really enjoyed this book. So if you want to create impressive visualizations, this is one of the books, or to be able to tell stories, okay? So mostly throughout our classroom interactions, we are taught how to create different data analysis outputs, okay? But sometimes they may not be able to tell the story. If you have every data has got a story, okay? And data V's is one concept or principle that if you know, you'll be able to speak or communicate the story behind whatever data that you have. So it is a very essential topic, but unfortunately, that's not what this class is. But this is part of data V's, okay? Being able to showcase or publish the work that you do. All right, so the shiny package. Before we come to that, now mostly what happens? We do our analysis. Okay, you sit behind your computer, and you know, one thing I love about data science or statistics is that you don't need to necessarily have like a brick and mortar lab, okay? Your lab is your computer. Once you have your lab and internet, you are good to go. But mostly what do? We sit behind our computer, we run analysis, some complicated analysis, and the results sit on our computer. Okay, but in the industry, it doesn't work that way. You should be able to showcase your work. And I know in the past, the tradition was that you create your outputs, you conduct your analysis, and then maybe you can use something like Word or PowerPoint, okay, where you transfer all your outputs and everything into your PowerPoint. But the challenge is will be what? Static. Like whatever you put in there is exactly what your user or your audience is going to see. Okay, that's exactly what they can consume, nothing beyond that. Okay, but in data science or statistical analysis, sometimes it is good to be able to interact, okay, with the output. Okay, or even in your own work, it's also good to be able to experiment, okay, with different output. Like, how does the model that you've built or the visualization that you've created, how does it change under some circumstances? Okay, so that's how dashboard or interactive web applications come into play, okay? And traditionally, this has been the work of computer scientists, okay? So there is something we call web development, and it's not new to you. If you have used, let's say, YouTube or Facebook, yeah, chances are high that's what you're already used to, the web. So by the end of this session, you have a fair knowledge of even how applications like YouTube is a typical app, okay? It's a web application. Why? Because it runs it's like a software, but compared to native softwares, which we call like desktop applications, web applications run in a browser. You need a browser, okay? Yeah, so interactive web apps. So let's say in the past, you just give your work to maybe a computer scientist, and they'll be able to create an API and connect your output to a web server. And then from there, you can showcase or publish your result to the world, and also give the user some abilities to interact with your outputs. But now, the focus has shifted, and even more so that now we have data science. It is imperative that as a data scientist or a data analyst, you are able to create such interactive applications by yourself, okay? And thanks to the good people at originally our studio company, which is now Posit, thanks to them, they came up with this Shiny app, and the focus is to make the development of interactive web applications easy, even for non-computer scientists like us, okay? So we use a computer, we write computer codes, we speak computer languages, but we are not computer scientists, okay? So some of these things can be way beyond your task. And the focus as a data scientist is not to spend so much time on developing some of these apps, okay? So those heavy lifting has been taken away through some of these apps that help you deploy your applications. And we are grateful to the Arposits company for creating the Shiny app. So as I said before, Shiny, so that's some kind of motivation. We'll get more into the motivations as we move on. Now, Shiny is just an R package, like I said, okay? So feel free to interact with it the way you interact with any package. You can view the help documentation for any function, okay? We'll be seeing more of that, which is a skill you should adopt. Mostly, the documentation is where you learn most of the key things, okay? So it's just like treat it like how you treat any of the native R packages you've been using. All right, now, you see, in data science, there's always this kind of controversy. Okay, which way should I go, R or Python? Okay, but like I always tell people, there are tools created for specific tasks, and R started as what? A statistical package. Okay, so it is more suited to the statistics world. Okay, but now, by the help of other developers, I mean, it's catching up in other space. Okay, but traditionally R was just built for statistics, and Python is multi-purpose. It's a versatile programming language that can do different things. Okay, but now I think in the data science world and machine learning, that is the top language now. So it doesn't hurt to know Python. And the good thing is that most of the things that we're going to be learning here, there is a Python version, okay, created by the Posit company. So you can look it up, Shiny for Python, okay? And so there are other packages available to extend the functionalities of Shiny beyond the basic ones that we'll be seeing throughout this session. So we have something called like the BSlib, which provides a library. So I'll be talking more about these things. And then the Shiny themes, also taking away some of the heavy liftings for you to be able to create very, impressive dashboards and applications. So there's even a Shiny dashboard, Shiny JS, yeah, more about that. Now, if you are feeling at any point in time, you feel overwhelmed, you can visit the R Shiny gallery, okay? It has, oh, why is the link not working here? Oh my. Okay, so apologies.
I can look for it and put it in the chat. So
I wanted to, yeah, okay, so just go to, just type Shiny gallery, okay? Shiny gallery. Today, I don't know, it looks like we ran out of favor, but we are good, okay? It happens. So let's see the Shiny. You can go here for inspiration, okay? Shiny Gallery. By Posit. Okay, Posit used to be our studio. It's the same thing now, just that they're expanding to include.
I'll put that in the chat too.
Okay, good. So our able president just put a link in our chat. You can also visit it, but it's the same thing I'm showing here. So in web development or even in software development, okay, mostly you rely on templates. Okay, it's not everything that you start from scratch. Even the computer scientists don't do that. So there are certain things we can abstract away. So you just plug them into your own application. And with the help of this Shiny Gallery, you can have access to such templates or widgets. Okay, so, but let's just take a look at some of the applications to kind of whet your appetites. Okay, so let's see what we can do at the end of this session. I think, yeah, there are cool stuffs here, but I think this one has been my favorite so far. So these are, there are full-blown like built applications that people upload even to this website. And if you're interested, you can come here and the codes are all available. This is what open source. So you can view the app, also view the code. All right. So it's a very useful place that you'll be coming, you see yourself coming back to now and then. So let's view the app to see, have an idea about what we'll be creating at the end of this session, okay, workshop, like this 3 parts workshop. Okay, so I don't know why it says it disconnected. This is hosted on, we'll talk about hosting, okay? This is on a free server, and I think one of the disadvantages is that sometimes after some inactivity, it disconnects you, but here it shouldn't disconnect at this point. I don't know, maybe there's some error going on down there, but it shouldn't disconnect. Mostly.
Yeah. Is there a way to deploy what we made in Shiny into local server,
yes,
like as an HTML file?
HTML file?
Yeah, or how to deploy it not into online servers, but like a local file. Like something you can send through attached to an email and.
Oh, okay. Wow. Well, I don't know about that, but currently what I would say is you simply have to give them the which is not a good thing, but you just have to give them the file. It's just an R file, okay, containing your codes, and they have to install, yes, and run it. And what's the point? Because the whole point about, but I know that it can be possible because in the web development world, okay, something that I do is web development. So web development, like I said, the applications run in a browser, but that is not entirely true, okay? We can also even package it into a desktop app, which I have done in the past. Like I create applications for like local churches, and some of them, they don't have the means to maintain the app on a browser. So I'm able to package it as a desktop app. So I give it to them, like they install it, and they're able to run locally. So I'm sure because RShiny is nothing but a web app. You will see, okay, we will go to the anatomy of it. We will look at what is behind the scenes, okay? And you see that it's just like any web application like YouTube. So that should be possible, but at the moment, I'm not sure if that feature or functionality is supported by RShiny, like being able to host it locally, okay? But you know, this or another thing I'm thinking about is I haven't done it, I haven't tried it, okay? But from my own web development experience, so what I do is usually when I create an application like web development, I have my local server, okay? I'm able to create my local server, which is usually like 127.000.1, and I can run applications on it. And since this is like a server, okay, You can run HTML. We'll talk about what the bare bone, the skeleton of a web application, which is just an HTML. An HTML you can run it on any application existing today, any computer that has Windows or Mac OS. Okay, you can run, you don't need any other things. The features that you need to run HTML ships with most computers or operating systems. But the challenge is the backend language. Okay, the backend language. And here R is going to act as our backend language. Okay, in typical web developments, like we have things like PHP, Python, okay, which acts as the backend language. That's where we need a server. Okay, the backend language only executes in a server environment. And that's where the challenge is. But there should be a way around. I mean, it can be a good project. We'll take it up. From here, we'll dive deep into the posits, R Shiny, to see if that is available. If not, maybe, well, it can be a cool project. So, yeah, good question. So you see that the server, it's not responding so well, but here is the code. Okay, you have access to all the code. And the app is here. You see a server.r, and we should be able to do this on our own. Okay, we should be able to understand all this structure when this workshop is over. All right, so I don't know maybe if it is just this application, but there are other cool things we can see. Yes, so you know that this workshop is very important, okay? So let's see here. You go to the user showcase. Let's try maybe, my favorite did not work well as I expected. So let's see this, view app. So at the end of the day, we should be able to create something like this, like tell people, host it, tell people, give them the URL. They can just type, like how you go to Facebook, and they will see the beautiful work that you did. Okay. How impressive is that? So this is what we call an interactive web app. So let's try to see if this is indeed interactive. Interactive means that, like, we have an application and it's not static. Okay, the application is able to respond to user interactions or behavior. Okay, like changing things. So let's see if this app is interactive. So I click on trend, and so typically this is what you see, the graph on my right hand side. Okay, if you look at the right, the line graph. So this is what you build in R, and it's usually static. If you want to make any changes to it, you have to go back to your R code and make the changes. But when you are working or you are developing applications or maybe any data science products to someone, the assumption is that the person doesn't know the R code, okay, behind it. That's why they even ask you to do the project in the first place. So if they want to make some changes, like let's say in their company, they want to see the mechanism, maybe the dynamics of certain variables in whatever that they are working with, they should be able to make changes for the application to respond. And in your R Studio, the only thing you can do is go back to your codes and make those changes. But with the help of these interactive web applications, we can make the changes without even having to know the code behind this app. So let's read. This is interactive because it's able to respond to user behavior. Okay, when we first loaded the app, it was showing, I think the first one, the default, the alcohol brief interventions, but I'm able to change this to even problem. Look, alcohol problem drinking. Look at how things are changing. You see how things are updating based on the selections that I make. So I can even uncheck this. What happens? It says no data. And we are going to do these things. They are not beyond us. Okay. So let's see. What else did they provide? So decide how to present the data in the chat. So at the moment we have rate or percent. Okay, sometimes, you want to be able to visualize or see your data on different skills, okay, measurement skills. So by default, we had rates. If you are interested in knowing the rates, the growth rate, or maybe you just want to know the raw numbers. And this is something that what your user will be so happy with if they're able to see different sides of your story or different sides of whatever projects that you've made. So any question at this point? So this is how a typical interactive web application looks like. And the goal is to be able to build something like this.
I got a question. I saw that we have the option to download data or this. Look, so in this app, we have to upload like our code, our data, all this stuff, and it's still free. Like
Yes, right now, okay, we'll talk more about the hosting, okay? So there's something called hosting or deployment. The whole goal is to be able to deploy the machine learning algorithms you built, or even the data visualization that you develop, telling the story within your data. So at the moment, there's a free hosting, okay, provided by Posit, which is called the shinyapp.io. So you go there, you create an account, and you should be able to host the application that we'll be developing. And I'll walk you through, I mean, at the end of the day, I'm going to teach you or demonstrate how all these things can be done so that you host your own app, okay? So on that free app, you upload the data, okay? All the data that you have. And a good way is to be able to save them in a more compact form, like in a zip form, okay, compressed, maybe using the data. R has some compression forms, okay? Instead of saving it as a CSV, you can save it in a different format like the R data format. I'll show you all of that, or the RDA or RTS, okay, which compresses the data so that it doesn't take up so much space. But for the application that you'll be developing right now, there should be enough space available for you to host the data that you have. But even if maybe in the future, like you are doing a mainstream application, like a big application, your company, or you can have your own dedicated server. Okay, you can have your own dedicated server with a huge amount of space to host your data, or even through APIs, you should be able to tap into other data. Okay, the project that we'll be doing here, I use API to download the data from Twitter. It's now X, but I like Twitter. Elon Musk, I'm your fan, but this one, I'm sorry. Okay, all right. So you can use APIs, like Twitter has an API that can help you even pull data directly into the app. Okay, so although there are so many possibilities that we can.
Can you connect it to, say, another database or another server? Of, let's, for example, maybe COVID cases, like during the pandemic. And so it will keep updating by itself.
Yes, I did an app like that. I don't have it hosted, but yeah, I can show you. I created a COVID dashboard during the COVID period. So with COVID, the beauty is that even I don't know if they are still maintaining it, but when COVID was full blown at the time, you know, there were a lot of data warehouses, like there were a lot of repositories with data, like giving you live updates. So all that I did was just grab the URL, okay, the link to the repository. I know John Hopkins had a repository for that and other repositories. So I just grabbed the URL, okay, and I tap it into my application, just like how you load any data using URL. You know that you can download data using a URL. Okay, yeah. So you just grab the URL, and as the maintainers of the repository update the data, your app will also receive a live update. And in R, you can connect to, you see that this Shiny app, it's when we take out something that is new to you, the rest of it is just like R that you've been working with. And anything you can do in R, you can do it here. And in your typical R, if you don't know, I'm telling you today that you can connect to a database. Okay, you can do SQL, like write SQL to interact with database. There are packages to help you create the database connection. Okay, all that you need is a connection to the host, the server where your data is sitting. And R has the capability to connect to databases. So yeah, you can have a live feed to your app. And that's the whole point and the beauty, okay, for our application to respond to even live data and other updates initiated by the user or even data change. Okay, yeah, good questions. All right, so yeah, that is so that's the goal. We should be able to create something like this, give the user options. All right, so back here, a few things I want you to know. So more about the hosting, okay? We will be going deep into that in our second session. That's a part 2. So please don't miss that session. Okay, and here are some resources for you. I think this slide will be shared, okay, so that you have access to the links. You can go to Getting Started, which is prepared by Posit, okay? It will just give you a gentle intro and maybe walk through. And then there is this material, a book, which is freely online, available online, called Mastering Shiny. Created by one of the authors is Hadley Wickham. Okay, he is the brain behind most of the work and arts Posit. And then outstanding user interfaces. Okay, if you want to dive deep into creating advanced dashboards, like very impressive, like something that catches the eye. And then I'll recommend this. Okay, the last one, outstanding user interfaces with Shiny. Okay, they'll teach you, show you some wonderful things you can do. And like I said, Shiny is nothing but HTML. Okay, so yeah, today we have to be able to create a basic UI, okay, which is the foundation of the complicated that R interactive web application that I showed. We should be able to develop the skeleton, the basic structure of it, the basic UI. Okay, attach some basic interactivity, okay, to the application. That is, our app should be able to respond to user changes. And then, yeah, at the end of the day, so that's the goal for today. Now, at the end, we will have a project, okay? I'll be sending the data after this session, so I can start playing with it. So we'll be analyzing what tweets, okay, or which is export. How do they call it? Expos. It's so weird. I don't know. I like tweets. Okay, so everybody here was born before 2023, so you should know tweets. Okay, all right. So we'll be analyzing tweets, and we'll do some sentiment analysis and yeah, other cool stuff. So that's the goal. So wait for it, okay? And we should be able to develop our own interactive dashboard for the analysis. And then here is a base app. So the base, I have the base here, but we are going to develop it together. In our third session, that's where we'll spend more time on the application, where we'll be doing something like code along. Okay, so I'll be coding it with you here. Okay, so that we'll go through all the errors. Sometimes you see a beautiful application out there and you'll be wondering, they also went through those challenges that you go through, okay? It's not always like a smooth process. You just pick your computer, you put in the codes and you have everything running. No. So we will do a code along for you to also have a feel, okay, of how it looks like to actually start an R Shiny web app right from the initiation up to the end. So that is the goal. And unfortunately, I cannot click this link again. It is too bad. Wow. The links were working. Okay, but the good thing is, I think I should have it. Let me go to GitHub. Okay, I think I'll also try and post some of the codes that we do. You want to pass a comment?
Someone has said it's working in my end. I don't know what's working in the chat box.
Which one is working?
Oh, that was recorded.
Oh, the New Zealand. Oh, okay.
Okay, so I'll go to.
I have your presentation. I can go and look at it, and then I can share it in the chat.
Okay, good. So I think I have it here. So another thing, maybe if there's time, we will talk about a little bit about version control, how to also make your codes available if it's open source. Okay. So the app that we'll be developing, this is the base. Okay, so here is the base, and we are going to think through and add other functionalities. Okay, as we go through the design and development process. But here is the base of what it should look like. Okay, this is the base. But at the end of the day, we should be able to add more features and functionalities to it. So this is just an application which pulls data from Twitter. Okay. Okay, thank you. So yeah, it's the same thing I have here. So it pulls the data from Twitter, okay, but now because the goal was to connect to that API so that you also have a feel of how to tap into data using APIs. Unfortunately, because of the change, I don't know what Elon is doing with X. It's not so free. Their API is available, but I think you have to purchase an account, something. So, but I already downloaded the data. Okay, so I'll share that data with you. And this is what? An actual tweet from Barack Obama. Okay, former president, Barack Obama. And the goal was to be able to know his tweeting pattern, okay, and some of the words that he usually use in his in his tweets. And this whole thing is, you can think of it as what? Sentiment analysis. Okay, so this project will also give you a little bit of insight into sentiment analysis if you've never done that. Okay, that's why I chose this project, because it's not something common that we see in our classes. Okay, so look, we should be able to do this basic thing. If nothing at all, you should be able to do this. But the goal is to be able to add other features that we are going to think through as part of the development process. Okay, now someone is behind the computer will be like, oh, William is talking too much. Yes. Always there's a temptation to go to your R studio. No, that you go there when you have a plan, else you'll be wasting your time. You have to conceive the idea, even make a sketch. Okay, I want to put this here. I want to use this color. Like if you go through the data viz principles, color is a very good tool. Okay, color choices. Like you sit down and plan all those before you come to your. So mostly in app development, your IDE or app environment here where you write the code is the last thing you come. Okay. Yes. So this is very important. So a lot of things have been left out in this app, and the goal is to be able to add it. So some of the things you can be thinking about it. Okay, the link is there. You have the link. You can look at it and think through what else you can add. Okay, but right now, some of the interactive features we have is that this data is covering tweets from 2014 through to 2020. So when you first load it, it shows you everything, which is a summary of all the tweets. Okay, the posts that he made. This ones exclude retweets. Okay, these are the original posts from former President Barack Obama from 2014 to 2020. Okay, so but you can change it to a specific year. You see what happened? So this is a global option that changes all the plots we have here. Okay, all the plots respond to that. So you see what is happening. Good. And now if you go to, so the goal here, now, one of the things we'll be changing is under the tweeting pattern, we want to be able to provide, let's say, a comparison across years. This one is a summary of all the years, but we want to be able to see that, okay, how does the tweeting pattern in 2018 compare to maybe another year, 2020? Okay, so we should be able to provide the user with an option to include the line plot maybe for different years, like you see all of them side by side to compare. So that's one functionality that we want to add. You can be thinking about that, okay, as we continue on, because there will be a break after this. You have more days to think about it. Now, another feature is what? Look at this common words. From the start, it shows, I think, the top 10, okay, but you are able to also narrow it down to even the top 4, okay? And then there is an accompanying word cloud, that shows you the most common word that President Obama used in the year 2018. So he was talking about people and votes. And this is something your company can follow up to see if this is a real application. Why world, people, and votes taking the lead here. So that is not the focus, but at least you also get that as a bonus, understanding a little bit about sentiment analysis. And here are the sentiments. So we can see that President Obama, mostly his tweets, if you want something positive to start your day, you can, maybe he's one person you can follow. Okay, this is some of the beauty of data science. So with this analysis, we can see that we can even do a comparison of different users. And maybe your goal is to find whose content aligns with your goals. And from here, we can see if you are someone who value trust, who is always looking at the positive side of things, okay, then we have someone you can follow, okay? Yeah, that is the application we want to develop. Good. So now back into the real thing. So every basic Shiny app, okay, has a skeleton, okay? So something I will call the skeleton. And this is inspired by the underlying construct, which is just what? It's a web application, okay? It's a web application. So let's look at this. If you are on any website, this is a website or a web app, okay? Just right click and go to view page one. Look at it. Okay, if you do the same thing for YouTube, you see something similar like that. So let's see this app that we'll be creating, which I've already posted the base parts. Okay, let's go to view page source. What do you see? The same structure, right? Yes. So there is an underlying skeleton, okay, which is enforced by the HTML. So web applications uses a language or a code called HTML. And we don't have to worry about the structure. So all that we need to do need to learn is that every R Shiny application has three main components. Okay, they have three main components. Okay, you have three main components. The first part is what? A UI. And the UI is user interface. Okay, user interface. And what we were seeing here, like if you come back to this app, this is the UI, what the user is able to see and interact with. So you have that component as part of the three main. So you define your UI, you define your server, okay? The server does the back-end operations or processes. And then finally, you assemble all together using the Shiny app function. So every application you see, no matter how complicated, okay, even though we'll be looking at some advanced form, we can modularize this one. We can factor the code and put the UI in a separate file, the server in another separate file, and put it all together. But typically, this is the underlying structure. Okay, you have your UI, your server, and then you assemble all together. So let's see. You can let's start. Okay, just go here, go to your RStudio, and under the plus sign or even the file, okay, you go to new, but I prefer the plus. Just look down there. If you already installed the Shiny app, you should have a Shiny web app. Are you able to find this? So yeah, this will give you the template to start with or a boilerplate. Okay, so just click on that. You're going to create your first Shiny app and provide a name. Okay, so usually this name that you provide here is what the app is going to use, okay, to respond, to be able to run. It's more or less like the name of the application. Okay, but so usually you just put, let's say first app. Let's just call it maybe first app. Okay, so this will create like a folder because every app comes with other dependencies which we'll be seeing. So you just give it a name. And there's an option, as I was talking about, you can have everything on one file, okay, which is nothing but just an R file. or you can factor them, okay, break them down into the main components so that you have your UI setting in a separate file, and then your server code also setting on another separate file. If you want that option, you choose the multiple, okay, but to make things simple, just start with the single file. And now click on the browse to see where you are uploading the application, okay? So right now, I have it pointing to my desktop. Just point it to wherever you want and go to open. So when you are through with that,
What will multiple file do?
the multiple,
Yeah.
this will help you, like when you're developing applications, sometimes the codes become extensive that you get lost in your own application. So the good thing is what we call modularity, okay? You break your codes down into separate pieces and then you assemble all together so that you can have a file which does what? Maybe all the data pre-processing. You can have another one that does another part, handles another part. So here in the context of RShiny, this will basically give you just the UI. Okay, you will see the structure I was talking about. It will give you the UI, just an R script, a dedicated R script file that has just the UI component. And then another dedicated R script that has the server component. Okay.
That's the case of the Twitter app you just showed us.
Yes, so that one, I think the code is just running on one file, but we can break it down, okay, so that it will be easy to navigate. That's the whole purpose.
Okay.
Yes. So just do a single file and then create. So it should, it looks like it's still showing me my old. This is weird. But I don't know whatever is happening with the computer, but if you did it, you should be able to have something looking like this.
There's another one then.
I don't see it.
Yeah, it's at the top.
Oh, okay, good. So you should be having something like this. And to be able to run it, all you need to do is just click on this run app. All right. And your application should be running. And now there's a default application for us. Okay, you're able to make some user changes. So make sure you have this. Are you able to run this? If you have any trouble, let's know. Our friends on online, let's know if you have trouble getting what we have there. At the top, if you are running this from, I'll show you another option, but if you are using RStudio, so that's another big assumption I made, is that you are using RStudio. So if you are using RStudio, once you have this, it should show an app, run app here. Let me close this so that everybody can see. So just in your RStudio, the top right corner, okay, you should see a green button that says run app. Can we see that? Yes, so just click on that, and if all the codes are valid, it will load your app and show you the beautiful work you have done. Okay, so right now it is opening. If you notice very carefully, you realize that it's opening in a new window. You can change that behavior by clicking here, going back to the run app. And you can choose even run in viewer pane. Sometimes you don't want to be moving between windows, like you are doing something and you want to really see it right here without going away outside of RStudio. So you have the option to, it should be able to work here, run in viewer pane. So if you check that option and you run, it loads here inside the viewer. You see, I have the app loaded in my RStudio. And this is very useful at the time of development. Like when you are developing, sometimes you want to experiment with some behaviors as you are coding. And sometimes it's annoying jumping here and there between windows. Okay, so that's why we have this option for you. You can do all the interaction here. You see what is happening. You see, without even moving out of what? Our studio. Okay, so just take notes. If you want to load it that way, you just click the drop-down menu under load or run app and just click on run in viewer pane. Okay, the default was run in window. So you just click on this and you see it's put it. So this is useful when you have done a lot and you want to see how it will look in the outside world, like how the user will see it. Any question about that? And there are other options. You can also load it in your external. Okay, if you do run external on my computer, usually this will run in my default browser. Okay, so if I click that and then I go to run, you see, it brought me to my default browser. Yeah, the reason why they have this is sometimes web applications, there's some challenge. When you develop something, it will be looking good to you. But if you try viewing it in another browser, it will change because of the browser specifications. That's why you need to try your app in different browsers, okay? But the beauty is that our Shiny comes with a library, okay, which takes that away. Okay, we will see that, okay? There's a library that helps you do all the aesthetics, the beauty, the color that we see in web applications, okay? And that one helps you. So for the most part, your app should be able to look the same as you see it on your computer. But that's not always true for web applications, unfortunately. Okay, so just take note. That's why we have different viewing options here. And you want to be able to test it in a real browser to see how it will look on your user's end. Any question? So that's the basic web application. Now, the goal is to build a UI. Okay, if this thing is looking complicated for you, I can tell you that you don't have to worry about this. You can create your own file. It is just like R, okay? So don't be scared to do the things that you do in R. So I can create a new file instead of using this option, Shiny Web App. So now we know one way to create your web app is to start with a template, which is given by this option here, Shiny Web App. Or if you are feeling so confident, you can create your own dedicated file, like how you do, like create just an R script. Okay, we'll look at how to embed our markdowns later. So R scripts, new, you save it like you always do. Okay, so I'm going to put it inside desktop. I think I have a demo here. So let's put it inside demo. And then we give it a name. So the name of the file, I'm going to call it maybe main app.r. Okay, it should be .r. Now you see, can you see the run app here? Does it show for you run app? If you did what I did, creating your own dedicated R file, like to start the Shiny app development. So what you do is, so like you always do, load your package, okay, Shiny. And then the next thing is what? Create the beautiful UI. So create the UI, which is the user interface, okay? So how do you do it? Just assign it to a variable. Don't be scared of what you see. It's just an R object. So create your R object like you always do. So UI, but we have to learn some structure to be able to create the HTML skeleton. And one structure which ships with our Shiny is the fluid page. Okay, so every web app, you see the page here, like if you go to your browser, the code should be able to identify all these parts. So the tab, the information you see on the tab, old faithful. Can you see the old faithful here on the tab? It's all part of your web application. It's something you can change. If you look at this, you see, it doesn't show us something good, but most of them are showing us something meaningful. We can change all of that. So you have control over all this space. So how do you target them in your development side? Okay, so that's what we are going to do. And today we are focusing on what is called like the body of an HTML. So the body of an HTML, it covers everything you see here. Okay, the plain white thing you see here, including the data, the slider, and the graph. So how do we manipulate this part of the browser? We need to be able to tell our application that this is the body, okay? So the body is where you put your outputs, okay, you display whatever you want to show. So you have this, okay, fluid page. You understand why, but later, okay, I don't want to dive deep into that. But just know that this is going to create a skeleton. I showed you a skeleton. We have HTML. It's just a basic HTML like this. Okay, you see how it starts? HTML. Okay, you use, these are the code, like how you write your R code. In HTML, we have codes. These are the instructions telling the browser how to position elements. Okay, so let's see if you're able to zoom in. Yes. Does this help?
Yeah.
Good. So we are trying to get this basic structure, okay, so that we can decide on what goes into the app, okay, the body part of the browser. And you define that using the fluid page. There are other options, okay? Now, the next thing you do, so you come back to put things in there. The next thing you do is what? Define the server or create a server. So you can assign it any name, okay, but this is a tradition, a convention. You can call it server or any name. It's
So-
just, it's an R object.
So what you're doing is that, are you giving the framework? It means that before you start any R Shiny work, you need to do the UI first. and
Yes,
then
the three components I mentioned. Yes,
that's the framework.
exactly.
It doesn't follow any other framework apart from this. It's
Yes.
strictly by this.
Yes. But the only thing you can do is that you can separate, you see, right now they are all sitting on one file, but we can break them into separate files. Okay.
What do you mean by separate file? As a separate sheet on this.
Yeah, like I can create a dedicated
Okay,
R
okay.
file and just define my UI. Create another one, define my server, and create another app, another file that will assemble the two together.
Yeah.
Like the three pieces can be separated and then piece together to run the app. Okay, good. So I'm defining the server, and this is a function, okay? The server is a function like any other function. Okay, it's good to understand this we can just start from here and work, but later it's good to understand how you can create your own functions in the future. Okay, so this function accepts an input, okay, an output, and then a session. But today we'll be using the input and output. Session is another thing, okay? When you go to Facebook and you are logged in, there is something that controls your session. Okay, there's the same file running, the same page you visit is the same file, but what changes is that there's a session which identifies the user. So we can also create something similar, okay, because this is nothing but a web application. So the session can help us handle those things, but we don't need it, okay? We don't need it. Unless maybe you are creating an advanced application and you want to give user privileges, okay? Sometimes you can limit what users see. If it is your boss viewing the app, you want him to maybe have an overall control. But if it is just maybe a worker, you want to limit some functionalities. Okay, we can give an option to even be able to delete files, delete items, and you don't want every user to be able to do that. So that's where the session can come in for us to even limit access. Okay, but for now, we will worry about only the input and output. Okay, so this is the basic. Then you come down here and run the app. Okay, so if you have your Shiny loaded, one good thing is run, when you do library Shiny, run that line, okay? You can just put your mouse there, control, if you are on Mac, just hit control, enter, sorry, on Windows, control, enter. On Mac, you can do command return, okay? So that it will load your application, but make sure you've stopped the app if it's already running. And then just run this line. And the good thing is that once you run the line, it will be suggesting some of the things for you. Okay, so if I know that there is something called fluid, okay, you see fluid page. It suggests it for you so that you don't have to worry so much. Okay, so I'll always, one thing I do is always load the library, okay? So that all those functions will be suggested for you on the fly. So you have a Shiny app. This is a function like any function, like how you call the LM function. The ggplot function is the same. And this accepts argument UI. Okay, so we assign it to our UI. We could have called it any name. This one, you can call it any name. What the most important thing is that we match it to the UI argument inside the Shiny app. Okay, then the next thing is what? Another mandatory argument is the server. And then whatever you called it, whatever name you gave to it, just provide it here. So this corresponds to this, and this UI corresponds to that. Now, let's save our changes. You see, as soon as I saved, even though I started with what? An ordinary R file, the moment I have all these things specified and I save the file, save the changes, you see, our studio is able to detect that this is what? A Shiny web app. And now we can click on it and nothing is showing. We have only defined the body, the blank space. Okay, so our work is to be able to what? Fill in the space. So let's go back there. So how do we fill in the space? Now there's a structure, okay? So the UI has a structure. The parent is the body. Inside the body, we can decide, like, you can give a banner, just picture how YouTube looks like to you or Facebook looks like to you, okay? You can lay it out, like it's a layout. So you can plan and say that the topmost part, maybe measuring 4 inches from the top, is going to be my header. The left side will be maybe a menu. The right side will showcase maybe my beautiful picture. At the bottom will showcase pictures of my friend. So you decide, okay? And that's the structure. So how do we do that? This is an HTML. And we can use HTML codes if you understand HTML. So there's a function called HTML. If you know the HTML syntax, just call this function and define your HTML codes. It will run for you. So just as an example, okay, if you're interested, you can look at HTML later, because if you know HTML, it will help you even create complicated extensions or customizations to the app. So there is H1, which create headers. And I'll just say that, okay, hello, friends, just like that. And I can end it here, H1, okay? This one goes up to H6. I can run it just like that. So let's save the changes, run the app. Right, nothing is showing. Okay. So you see, I put it at the wrong place. This is some of the things. It's supposed to be in the UI, okay? The UI. So don't forget the UI. You see, now what I put there is showing. So everything, anything you put there, you can put any random text. It will show, okay? But you have to make sure if you are putting random text, you have to make sure you put it inside the HTML function and you quote everything, okay? Put it in this double quotes. You can put random, any, like they should all show up. You see? So you can put anything you want. You have control over the browser body. And if you are lucky to know HTML, then you are good to go. But that's why our Shiny is there. So you don't have to worry about that, okay? We will come back to using this HTML. So I'll just comment it here, just for our reference. Okay, you can select everything like that to comment all of them and press Ctrl-Shift-C. If you're on Windows, on Mac, Command-Shift-C. Now,
when I run my own, the H1 also appeared in there.
Then maybe it probably didn't close it. It's a tag. So watch carefully. Do you have a starting and an end like this?
Yeah.
Check carefully.
Yeah.
And you have the HTML.
Yeah.
Isn't it?
I think there was no HTML.
Yeah, make sure you have it in this HTML. So this one is very useful, okay? There are sometimes you want to do something, but the developers of Shiny app have not yet created a function for it. But you are not helpless, okay? If you know this HTML, which I will be using it to do a lot, maybe in our next session, okay? So it is one of the key functions you should always remember. If there's something that you don't know, or maybe our Shiny doesn't have it, you can go to Google, type, how do you insert a link in HTML? They'll give you the HTML code. Just copy it and come and place it inside this HTML tag, making sure that you put it inside what? The string, like the double quotation marks. And it will work for you. Okay, so it's very, very useful. Okay. Any more questions? All right. Now let's design the structure. So before we close, we have a few minutes. So let's use maybe 3 minutes to define a full-blown structure. Okay. Instead of us, traditionally we have to use the HTML code to divide this blank page. Okay, decide that, okay, we want the plot to be here, we want the slider to be here, but we don't have to worry about that. Our Shiny has functions to do that. Okay, so one of the functions that you can use is a sidebar. Okay, we can start with the sidebar layout.
So we create all in the UI.
Yes. The UI function.
Okay.
So the fluid page, there are different functions, but for now, let's just stick to the fluid page.
Okay,
Next
so
session, I'll explain
so
why.
UI as in terms of user interface.
Exactly.
So, okay.
This
And
is
I
what
get-
controls everything we see here. Okay, so whatever I want the user to see, we put it here. And then we use the server to handle changes. The server is like the back end. If the user come up here and change the slider, how does the plot respond? It will be handled by the server. Okay, but for today, looking at the basic UI. So we create a layout. We want to create a nice layout. So we have a sidebar layout. So you create a sidebar layout. Any question? Any trouble over there?
Yeah, mine is not.
Okay, so within this is going to divide our page for us without us doing anything. So we can have a sidebar layout. I want to put a sidebar on the left and then a sidebar panel. So you have a sidebar panel as a function. And we can define all our sidebar inputs there. Then another thing I want you to take note is that we can put different functions inside here, okay? Everything to define the UI are going to be different functions. And per the our Shiny syntax, we have to separate different functions here using a comma. Okay, so I have the sidebar indented so that you can see every part of it. I have this one here. And then my layouts, that's the last one, so I don't need a comma. If you have multiple things, and this one, there's only one, so I don't need a comma. But if you have multiple functions nested, you need a comma to separate them. Okay, so take note of that. So I can define that sidebar panel, and we will have the main panel. So still, okay. Then we define the main panel like that. So this is maybe the main panel or main body of our application. And there's another function called main panel. If you load your package, it will be suggesting all the functions for you. You don't have to remember or just know that, okay, there is main, you start typing, pops up. Okay, so inside main, we put our hooks. Now, do you notice something? Our studio is telling me there's an error. Why? Like I said, whenever you have nested different functions inside the fluid page, you have to make sure that you separate them by what? Commas.
That's an extra parenthesis.
Okay, so this one runs all the way here. The sidebar is one component, it's a whole function, and we can put other functions inside it. So whenever you are nesting functions inside the UI, separate them with what? Commas. So the reason why we had the error is because at the moment we have two main functions, the sidebar layout and the main panel, and we need to separate them. Okay. So if you run, you will not see anything much, but at least it should show you the layout. It says what? Okay, I think this one should also come inside here. Yeah. Yes. So you see, we have, can you see two main parts? We have the left and the right. Okay, now let's go and provide some inputs. So if you want to take input from the user, there are inputs. So there's something, a notion of inputs that you have to understand. Okay, from this UI. Inputs. You need input to do most of the things. Let's say you want the user to be able to change their name or provide their name. You need an input. You want the user to upload a picture. You need an input. So the notion of an input, and there are different inputs. So we have some like, if you want to do a free test, we have like a test input. Okay, and every input has something called the ID. So you put the ID here, and the ID is what we are going to use to track whatever information the user provide to us. And then we provide something. So we can say that enter your name. Okay, like that. So we have our first input. So you need to learn these functions. Okay, and the book that I shared, some of the resources, Mastering R. If you go there under basic UI, you see all the various inputs. Date inputs, free tests, like for the user to enter anything. You see, enter your name. I can say William. And then there could be a button. Once I click it, the app picks my name and does something with it. Okay, or that could be even an information to an app to change something in, something in the plot. Okay, so that's how to create user input. And then once you are done, another thing you have to understand is what? Output. So you have to know how to put in your inputs and then outputs. So output is something that comes out of your app to the world. And the input is something that helps the user provide data so that we can process it. So we have input, output. Okay, so these are key notions you have to keep in mind. So the output, there are functions to also do it. So let's say we want to show a plot. You just do plot output. There's a function called plot output. And you need to give it an ID, something we can track. So let's say iris plots. Okay. Then, so we run this. We are not going to see any plot yet. So that's where the server comes in. So the server is what you use to run the R codes behind your app. So let's say that we want to display a plot.
Sorry, William. In the text input, we set two parameters, right? The second one is the one that appears in the HTML.
Exactly.
And the first one is
the
what?
ID. That is what we are going to use to track whatever value the user provided in the app.
So that would
Like the
be
label? Sorry.
The label, this one, there is not much rules about it. This one is what you want the user to see.
Yes,
Mostly to
but
be an instruction to the user.
Is the ID the first that you put the brand beside the label?
I'll call it, it's more like an ID, like something that identifies. We are going to put different components on the app, and we should be able to tell that the user interacted with this, the user chose this, and this is a kind of a unique identifier that will help us track all those inputs on the app.
So we can put like
You can put any name. Good. So you can even, which is a good convention, like give some descriptive name, something that speak to whatever input you're expecting.
so
Yeah.
that
So you can
would
name
be-
it. You are free to name it anyhow, but don't leave spaces. Okay, because we'll be tracking that. If you want space, just do maybe hyphen, name, unique, or something like. Don't leave spaces between them.
And
Good.
that will be like stored underneath, like a variable name equal.
Exactly. So it will be stored and we'll be able to capture it in the server using this input argument here. Yeah. So let's see, we are going to track all of that. Then, so the first thing is what? Now the outputs. How do you show the outputs? You come to your server and you call the output argument. Okay. Don't worry, next session we'll do more because we are through with all the introductions. But understand the basics. So you call this outputs function here. Okay. All the output that we decide to send to the app, we can capture them through this outputs and do something with it. Okay, so if I put plot output here, I'm telling the app that position the plot in this location of the body, the main panel. I can put different ones there. I can even put another plot output and give it a different ID. Okay, so that we'll be able to track all of them. This is like what? A second plot hyphen maybe plot. And we can target all of them. So first, I want to target the iris plot. So I do $output, view this as what? Think of this as like a list, the list that you have in R. So when the app runs, every ID, input ID, and output ID that you supply, they will be available in the inputs and output respectively. And it's like a list. So where?
After the first plot out, Irish plot.
Good, you see, good catch. Okay, so everything is available to you inside this input. Input is what the user provided, output is what you are sending to the user. And you can capture all, it's like a list. So just do output $, the name that you provided, the ID that you provided. So here we call it what? Iris. Sorry, I have to just borrow 10 minutes of your time, if you don't mind. So we called it Iris. We do $Iris what? Make sure that's why it is good to provide descriptive names, because this app is going to grow and sometimes you'll be typing something on the 100th line. You don't want to be coming up. So sometimes you provide descriptive name, even though you are down there, you can easily remember the name. Okay. So we call it Iris what? Plot. And then you assign this one to a rendering. Okay, so there's another notion of a rendering. So you have to be able to render the output. And there are hooks available. So if you want to render a plot, there's a function called render plot. Okay, and you have it like this. So now this will target this part for us. Now we just want to maybe create a histogram of iris data. Iris, let's take maybe sepal length. So when we run the app, it should show us this.
Can you go back into the code?
Okay. So out of the box, all these HTML parts have been created for us and we just have to learn the functions. Okay, so go to the resources that I shared here. Mastering Shiny. There is a chapter on basic UI. It will introduce you to all the UI components. Kwesi, do you have a question?
Go back, you need to go back to the.
Okay, so we are about to wrap up. If you have any question, you can drop it in the chat. I think there are, okay, no question at the moment. Is it working for everybody? Today is just to be able to get the app running. So if you're able to run your first app, that's the goal. The goal is to be able to develop a basic UI and understand the structure a little bit so that next week, in our next session, we'll just be into the code, okay? Learning more functions. So now you know Shiny. What is left is what? For us to learn and become familiar with more functions to help us include more what? Functionality and interactivity into our app. Yeah. Any question?
I realized that before you run the app, the code section, the console must save before it runs.
Yeah, you have to save your current changes. That's true.
Before you
Yes,
run it.
before you run the app, you have to save, and it will even prompt you if you don't save. Okay, so when it prompts you to save that particular
Yeah.
file.
But I also realized that when I run it, in my console, it's still running stop, but the output is showing.
The output is showing, but if you stop it, you cannot react. Okay, let's say I stop this here. You see that there will be a change in behavior. Look, it blurs. It tells you that it's not active.
So as long as
Because the server is not running.
okay.
And that's how YouTube works. Like Facebook, all the web applications you've seen, they are hosting files like the R files we have on the server. If the server dies, Facebook will not be available. So it's the same thing. Now it's like our server is dead. Okay, so if you refresh it, you can't do any change. Any other question?
So why in the where did you use the input panel?
The input panel.
Yes, so
That one is another, those are other functions. There are so many functions to do. You can create panels. Panels help you divide, okay, the page into some meaningful pieces.
and since you deleted that and you just put text input, that will default it by
Yes, so what I want is,
that side.
now you see our server is dead. Okay, Kwesi, so I have to go and run it.
Yeah.
So that's what gave me this, okay?
Yes, but since you don't put the input panel,
Mhm.
because you deleted that, you just put text in,
Yes, that one is
That-
enough.
that will just like, by default, it will put it like on the left. top.
Yeah, on the left because I have it inside the sidebar panel. So our page is divided into two main parts at the moment. We have the left side and the right side. So the left side is what we are calling the sidebar panel. So everything I put inside here will appear on the left side. And then the other half of the page is defined by the main panel. We start from here and ends down here. So whatever I want to show on the right, I put it inside the main panel. It's just enough to put them there and they'll display at the right places or positions that you want.
And can
We'll be
you,
creating more complicated layout, but this is simple.
can you split it, because now it's split into two, but can you split it in like?
Yes,
4 or 5?
yes. If you are curious, we can. There are so many, like I said, there are so many ways. And for example, let's just demonstrate that right now. Okay, if you wouldn't mind and you have I mean, I'm available, I'm not running to anywhere. So but the session, let's officially, okay, the session has ended. Okay, but if you are still interested to stick around, I'm available here. Okay, so let me people are going. Okay, and before you go off, please, we want to show you the email. Okay, if you are here and you are not part of the ASAP, please visit my Mind Tracker and search for ASA, American Statistical Association, okay, UTEP chapter, and join for us so that you receive what updates and you'll be able to track events that we have running.
Okay. Yeah. So the later announcement is next week we are not having a workshop because it's a spring break. But after we come back from the spring break, we will continue with this. We are moving on more to the advanced method and then try to do the project he's given. So I'll
be sending the data too.
So at this moment, officially we've ended today's workshop. But if you want to still stay behind and ask questions, you can.
Yeah, even for the next 30 minutes, I'm available.
So thank you very much for joining and hope to see you after spring break.
Yeah, thank you so much for coming. We hope to see you in our next session. Okay, but I'll be here even for the next 30 minutes. If you have the time, I'll be here to answer more questions. All right, so the question that you asked, we have control over everything. Okay, so let's demonstrate that. So that we want to be able to what? Even divide our page into more granular pieces. So the question you have to ask yourself today is that, okay, and Google is available. You just ask yourself, how do you create rows? So you can just say shiny rows or Shiny div, okay? div is more HTML, so it will understand it better. But I am here, so I'll be your resource for today. So all that you have to do is, there is another function called fluid row, okay? So we can divide our page into rows and columns. You can view the HTML page as a grid, and we can divide it into different grids. So the first one is a row. So you start with a row, and you can now break that row into columns. So what we did first, we had a main row, and we have divided that row into 2 columns. So the same thing we are going to do for the main parts. So just watch. So here, you use the fluid row to define a row. And don't forget, I hope that in future, the creators of RStudio will be able to do something so that we don't have to type the comments. Okay, yeah, this is an engineering work. I'm sure it's possible. But for now, let's bear with it. So fluid row, I've defined a row. It's invisible, you can't see it. Now, the next thing is to define a column. So there's a function called column. Okay, so I put a column there, and you see where the first one, can you see the pop-up? If you first create the function, it's a function, you can check the documentation, but the first argument is a width. Okay, that will help you decide how much, you're welcome, how much of the page you want to give to each column. So we can use the width argument. Okay, so something I'll be talking more about next week is that the page is being controlled by a library called Bootstrap. Okay, that helps you. Don't worry, it just helps you to divide the page into like 12 equal grids. And we can pick each one of them. Okay, every part of it, we can divide it into 12 equal grids. And you don't have to worry about that. So the creators of Shiny have done the work. All that you have to do is that, okay, that 12 grid, how much of it do I want to allocate to each column? So you can just say, okay, I'll allocate 6. Yeah, 12. So to break it into 2 equal halves. Okay, so you put a 6 there, you can add more arguments. Then you bring a comma. You separate the argument. So the first argument is the width, and the rest is what? The output, whatever thing you want to show to the world. Okay, so that will be the next argument. We can add other arguments. Now, I want to put this plot here. Okay, indent your application. Indentation helps you read.
William, please can you make it bigger? I can't.
Oh, sorry. Is it okay now? Good. So now we are creating a grid. We have a row, we are dividing into 6. We have taken the first 6 parts, and we are saying that we want to put what? The iris plot inside that first 6 parts. The page, every row, we can divide into 12 equal grid, and we are picking the first 6. So I can create another one, okay? We can put multiple columns inside the row. You are not limited, just separate them with commas. And remember, I said it's what? 6 equal parts. This is more about the web development, but now you know, okay? The page is divided into 12, and we can pick each one of them. So right now I'm picking 6, 6. And down here, I want to put another plot. So let's say I'll put iris plot 2. Okay. Now let's run. If everything works fine. Okay, so there is an error. If you come here and you are not seeing what you expect, it means there's an error.
We don't have to like add them to the server.
Yeah.
Good. So, I mean, that shouldn't be the problem. You can create an output without targeting it. Yeah, that one shouldn't be a problem. But right now, let's see. So you can just, when something like that happens, just try and comment out what you started with, the new changes you made. Okay, you go back, oh sorry, run the app. It's working fine. So let's see what we did wrong. Undo. Yeah, everything looks good to me. Hold on. Let's see. Yeah, this is weird. Everything looks good. We have the fluid row, and inside it, you can put a column. And then whatever you want to. Wow, this is strange. Yeah, that's the structure inside main panel, row, column. Okay. This shouldn't, you can create without targeting them. Oh, I know the problem. Remember, this is very good. I told you that the IDs are unique. That helps you identify the individual thing. So right now we are confusing the application because there are two output endpoints with what? The same ID. Can you see? Yes. So that is our mistake. So we make this 1, 2, and make this 3. Good. So yeah, when things like this happen, don't be scared, okay? Based on the understanding, how you understand the thing to work, you should be able to figure things out. That's how you're able to decode things. Okay, so remember that information I said. It's simple, but you see how it's almost messed us up. The IDs, you don't have to give the same name to different IDs, like different elements, the input and the output. Okay, so good. Now you come down here. Let's just duplicate this for demonstration purpose. The good thing is inside the server, you don't have that constraint of having to separate every function with commas. You don't have that constraint. So just put it there and then paste another one. So let's target the correct one. So remember, output is like a list. And when the app runs, all the IDs we provided for the output endpoint will be available inside output. And like we always do in R, just pick the name of your list and then $, the name that is available inside it. So we have output $plots. That's the first one. The second one was what we called it output iris plot 2. The third one is what? Iris plot 3. You run that, make sure you save it. And you see? Can you see?
Yeah.
So yeah, we have great flexibility. Like we can divide it into different parts. And like I said, view this as a 12 grid. The whole page is a 12 grid. Right now, I split it into 6 equal parts. If you don't believe it, okay, like me, sometimes I need evidence. So let's put here 4. Let's change this. And now we just do this. Look at what happens. You see? And this is, so we have to be so thankful to the developers at our studio. I have done web development and I appreciate what is happening so much because when I started web development, it will take me a lot of time. Like I have to write a lot of codes to be able to create this layout. But everything comes out of the box with Shine. Okay, so now you are beginning to think like how possible it is to publish all the work you do, including even your model. So as part of the application, you build a model and also deploy it on the project, that final project that we do. Okay, so that is it. You have control, okay? You can do so much. So right now we divided into what? You can just say that, okay, you want to use all the space. Let's say 4 here. And then you want to have another column. You just create another column. Remember that you have to your availability 12 grid. Whenever you are inside a row, you have 12 grades. So now let's do the calculation. I have 4 here, 6 here. What is left?
You have 12 grades.
Yes, 12
You
grades.
have
So 2. So I just put 2. And if I also do this, let's say call this.
You cannot exceed 12 grades.
Well, there is a challenge in web development, which called we call it what is the name? Responsiveness. Responsiveness, like how you see web apps are viewed on different devices. I can view this application. If I host it, I can view it on my phone. And if I'm viewing on my phone, the space is small, but the app should be able to adapt and pull things vertically. So if you observe, sometimes you view a website on a desktop or a larger screen, it shows all the parts. But when you go to your phone, everything becomes like what?
Yeah.
A grid, like just one row, vertical row, and you are scrolling through. It's all because of these notions. Okay, we call it responsive design. If later you want to dive deep into web development, you learn more about that. But for now, let's just say that that is a way to help us create applications that can even respond to different devices. Okay, the 6th grade. There are different ways. There are advanced ways. Flat and Flexbox. Okay, there's something called Flexbox, but we don't have to worry about that. So just think of it that the grades are helping you to lay out your page so that even if your page is viewed on a small screen, okay, let's say we minimize this. Look at what happened. You see, we are still able to see, okay? And in a more responsive environment, you see what is happening? It's because of what? That 12 grade layout. And it would have taken us a lot of time to build this, but everything comes out of the box. Okay, so remember that key thing. We can divide our page into rows and columns, and every row we have the ability to pick like 12 grades from each row. Okay,